Good afternoon, everyone. My name's Leonard, and I'm from the IBM Runtimes team in IBM as the UK lab. I'm actually the technical lead for the OpenJDK and Adopt OpenJDK team there, and I work with the Eclipse OpenJ9 team in Ottawa and Toronto in delivering OpenJDK with OpenJ9 Adopt. And also contributing changes upstream to OpenJDK. So that's my main area of expertise. Today I'm talking about Java serialization, why we still need it, how the built-in design is potentially flawed if you use it wrong, how it can be exploited and used against us, and what we can do about it, and why potentially other forms of serialization are still open to attack as well. So, why do we need serialization? So, in the world of distributed Java applications, Java makes life very easy for doing things, and we can replicate objects by simply using the serialization API to a remote JVM over whatever form of byte stream we care to replicate the object instances in a remote JVM, very simply. Common use cases of serialization, some more historic than others. So JPA, persisting Java objects of a database, remote EJB invocations, RMI, our good old friend Corba, Object Request Broker, JMX extensions, JMX MBeans, all forms of serialization occur there. And to a lesser extent, CDI, HTTP, HTML, and REST type services all involve serialization to a certain extent. If you go to GitHub, just type object input stream, you'll find lots of hits, millions of hits on that class, and that is the one of the main classes as we'll come into for Java serialization. So as you can see, widely used in the world of open source. And it's easy to use. Java's good at that, which is great. You just have to opt in. Implements Java I/O serializable. Simple as that. And here's an example. So with a few lines of code. So in this little example, my class thing, which is implements Java I/O serializable. In this case, I'm going to serialize it to a file, so I create a file output stream. I then create an object output stream, which is the serialization class library, from that file output stream. And then I write, using the write object, my thing class instance m. So I've got an instance of thing m, and I write that object to the object output stream. And it writes that serialized byte stream to that file output stream. And at the other end, so that file somehow gets to the remote destination that's reading that file, in this case, with a file input stream from the input. It creates an object input stream from that file input stream, and then simply read the object, and I've got my thing T back again exactly as it was at the other end. Nice and simple. So if thing wasn't implementing serializable, then when you try to write it, you'd get a Java I/O not serializable exception. So hey, it's safe to a certain extent there. If you haven't opted in, you can't be serialized, can you? So good so far. So as we've just shown, Java serialization is useful. relatively easy to use, but there are potential side effects. So you need to know what you're doing. So let's go into a bit more detail. So here's a simple example. I've got a simple class that implements serializable, a single instance variable, hello string, and we write that object, and you end up with a byte stream, something like that. And this is a rough map of what's in that byte stream. And you don't need to know too much detail about some of the bits and pieces, but there are some key things. So serial version ID, so this is basically indicating the serializable version of your class. So when you're doing serialization, you'll come across sort of a term serializably compatible changes and things like that. So you can only serialize into using a class definition which has the same serialization version ID. So you have to be wary when you're, because you might re-implement a class, totally change its instance, and obviously that's not going to be serializably compatible. In that case, you change the serial version ID, okay, to indicate that, and that would prevent it being incorrectly serialized at the other end. And as you can see from the other contents, it's self-defining the instance that we happen to have serialized here in this little example. So you've got the field here, my field called hello, which is a string and has a value. So it's defined everything with respect to that instance, including what the actual version ID of the class definition that it's an instance of. So, serialization. You can easily turn a graph of objects into a transferable form and back again. Great. So, the actual content of the instance is self-defining. So here's our example again. And as you can see, the hello field name is a Java-lang string. What happens if we do this? So I've changed class name. So I've manipulated the byte string to change the class name to a number. I've changed the value to an integer of 1. Let's see what happens if we try then to deserialize that. Great, you get class exception. So it's attempted to deserialize the object input stream. It's created an integer value and then trying to assign it to hello, and of course that's going to get a class exception. So it sounds like we're sort of safe there if someone tried to manipulate our data, changing the types of the variables. So are we safe from changes to the serialization stream then? Question. Let's have a look. So what can happen, because serialization is very easy, you can get carried away, you think, oh, I can define anything in this and just serialize it. So here's our example. I'll set a little example again. And I could think, oh, I could store any old thing in here. I'll change it to object. And then I can, there's my object, which would mean I could then equally deserialize a stream that had an array in it, because that would assign nicely at the other end. Well, the class library code's not going to know any better. Equally, hash map. Equally, any class. So you can see the potential dangers of getting overzealous with not being really type specific on in your class definition. Is a self-defining data stream dangerous? So we can see it can happen, but how could they leverage it, the bad guys, as it were? So here's a simple class foo. If we were to construct one of those, static initializer would get called, followed by the constructor, default constructor here, and it would output those two messages. Say we got a serializable foo and placed it into the serialized data stream of our simple OC1 class. Okay. What happens now if we try to deserialize foo into OC's one hello field? Okay, so here's our foo again, the implement serializable now. You've got those two messages. What gets called? A and B, both or neither. So remember, we know this is not going to work because we've tampered with it and it's not going to match the string. So we get a class exception. However, the static initializer is still called on my foo. This potentially dangerous class has come from somewhere that's been constructed. And notice cannot assign instance. So it's actually built an instance of foo. It failed trying to assign it, so we're protected to a certain degree. But you still need to be wary that deserialization can be used to execute code, even if it eventually fails. Okay, which can be still useful to the bad guys. Okay, so let's take that a bit further. So we've just learned that constructors do not get called during deserialization. Basically, because the byte stream is self-defining for the instance, it basically, the class library code constructs the instance during the deserialization without construction. So here we go, we've got another foo, implement serializable. It has a constructor that initializes data, and it has a size method that returns data.length. Okay? So here's a serialized stream. So here's a valid stream. And you can see our data field there with values 1, 2, 3, 4. And it's an array of length 4. So we deserialize it and call size, and the answer is 4 in that valid case. But what happens if we do this? We manipulate the byte stream and change the field type to null, and change it back, corrupt it from what it was before. As we know, the constructor doesn't get called during the deserialization. So that code here never gets called. So we create a foo object, and it's still valid, but if someone then calls the size method on it, data's gonna be null, because that's what we defined on the byte stream. So here we've the bad guy here has manipulated the byte stream to effectively corrupt our data. Okay. And it's not just implement serializable instances that are at risk. So you need to be aware. You've got a parent class, So I've got a subclass here, extends parent, implements serializable. So this class just opted in its parent. Now you can do this if your parent has a default constructor, because what the class library code actually does as part of the deserialization, to construct it, it will call the default constructor for the parent class, so that it can then deserialize the subclass. So if we go through that sequentially again, just to make it clear. So I create a new subclass. So you get the parent class initialization called, subclass class initialization called, parent constructor and the subclass. So standard construction of a subclass parent relationship. We serialize it, say, and then we deserialize the subclass instance at the other end. And this is what you get. You get parent class initialization, subclass initialization, so that's the class definition initialization. And then you get just the parent constructor. Okay? So those three are called, but as we know, the subclass constructor is not called. But the parent constructor is. Okay? So you think, well, it may be okay, but it depends a bit on who authored that parent class. Did the author expect it to be part of a serialization story? Question. May or may not be an issue. Similarly, so foo impl, so obviously a common practice, implements and ifoo. Is foo impl serializable? No, of course not. But it is now, okay? Fairly obvious, I guess. But just be wary that, a team of people working together and someone slaps serializable on an interface, suddenly affecting potentially numerous classes that might not have expected to be in a serialization story. Okay? And who might not have considered the implications of where their objects are going to get streamed. So Java serialization is a great gift to the bad guys. Is it something we really got to worry about? How many vulnerabilities, serialization vulnerabilities are out there? If you do a simple search in the CVA databases, you'll find many hits, as you might expect, looking at the potential attraction of what you can do. So, can we be safer? How can we protect ourselves a bit more? A few things we can do. So you can opt into deserialization and take more control. You can limit, if you really limit what's getting put on in the serialized byte stream. So if you use transient members won't get serialized. And then implement your own read object, which then reconstructs the complete object instance from what is on the byte stream. Now, that protects you a little bit. You've sort of really thought about what's the minimal bits of information I need, but I don't need the other end, as it were, or can be recreated at the other end. But it's still open. It still represents the instance in some way. So it's still potentially a problem. So other ways to reduce exposure. Opt out. So if you had a private final read object So read object gets called when it deserialized. That throws an IO exception, forbidden. So, this sort of helps protect you if someone does that interface change to add serializable. You're going to complain with an IO exception if someone tries to do it, or if someone tries to extend you similarly. Okay, so that's sometimes worth doing if it's something you really don't want to be serialized. JDK offers you some help as well. There's a Java security filter called JDK.SerialFilter, which can be specified in the Java security policy. It can also be specified on the command line by a system property. And that can help in a few ways. You can whitelist or blacklist packages or modules which can and cannot be serialized. And you can also prevent untrusted modules and also limit serializable array sizes, which is useful for things like potential impact of denial of service type attacks. If someone was to flip your array size to 10 million and you then try to do something with it, that might not be good. So implement class filtering, serialization class filtering. You could implement your own object input stream. So some people have done that. So take control, and you have your own native trusted way of doing it, rather than rely on the Java class library implementation, and put your own controls and validation in there. A lot of being security aware as a developer is typically input validation. That's a good part of the story. If you validate your inputs a lot more, you're stopping the bad guys, at least to a certain extent. The other thing with deserialization, you have to have the class definitions at both ends, the serializably correct class definitions. So if you can limit or secure what's available in terms of class definitions at each end, it limits what any attackers could utilize against you. So making use of modularity is a potential way of doing that. So you could J-link your own runtime to limit to just classes that your application needs. So good use case for modularity there. Another way is to create your own transfer model. So you're still serializing, but you're taking a bit more control in what's allowed to go down the wire. And you can do, because it's very consistent, you can put your own validation model as part of that transfer model to help protect yourself a bit more. Or you can go the whole hog and stop using native serialization altogether, move to JSON or something wild and wacky, something different. But you've still got the same problem, and the typical secure engineering issues, validating input, securing the network and all that. If people can tamper with your transfer. And JSON is typically used in REST services, and if you query the CV database, you'll find plenty of REST plugin vulnerabilities, for example. So switching to alternatives is not always a panacea. So just summarising that a little bit. Protecting yourself against serialization exploits is hard. And remember, it's not just your code, it's all the dependencies too. the self-defining design of Java serialization is open to exploitation because, you know, it's great in what you can do, you know, create this object. It's coded in the byte stream and then constructed at the other end, which sounds great. You just need to be aware of what's potentially could change if someone could tamper with it. So it comes down, you know, it's all about writing the code you have, but maybe not the way you expected if someone changed it. So how do the bad guys do this? We said data manipulation, denial of service attacks. As I alluded to, you know, if someone changes that max int count and you've not set max arrays, then that gets processed by your back-end application and starts looping for that many times. It's not going to be that happy, is it? So take care, or it just runs out of memory, as the arrow indicates, and takes your whole server down potentially. So discovery. So looking at from both a penetration tester type perspective or the bad guy's perspective. Fortunately or unfortunately, depending which way you look at it, there are tools out there to help from both sides. Shodan is an example, which is a search engine for the web, as they state. It basically searches for all interconnected devices and sort of pokes at them to see what's there or listening. Which, you know, it could find some nice RMI ports that it could start playing with and see what happens if I send some data there or something. Which is not so good necessarily if you're not being so careful. So exploits, so existing vulnerabilities. So there is an exploit database. So this is the key exploit database, which basically an archive of all the exploits and vulnerabilities, which is, you know, key for security experts, penetration testers, and unfortunately the bad guys who might want to say, oh, I didn't know about that. Let's see if we can find somewhere from all those Shodan discovered endpoints that I could take advantage. So that's the problem, you know, and that's partly why you've got to keep your OpenJDK up to the latest CPU PSU update. Yeah, my team gets involved in delivering those every 3 months that adopt OpenJDK, and you know, there's a numerous list of CVEs in each update every 3 months. And those CVEs, you know, they're only published. We publish the code. They're done by a secure team, the Java vulnerability group, and the CVEs are not published until the fix is up there. But as soon as the fix is up there, the exploit is known. But OpenJDK has already been fixed, so that's good. But it's only as good as long as you've got it on your server. So make sure you've got a mechanism for updates and apply them. So lots of tools out there, but does it really matter? How much risk are we taking by ignoring the problem? I think you might know the answer to this one. So look at some figures and stats. Cybercrime in 2016 was worth an estimated 450 billion. This drug trade was actually less than that. That doesn't sound good, does it? And cybercrime is the most profitable type of crime. It's also, unfortunately, least risk to the criminal, growing the fastest, hardest to prosecute, and you look at some of the predictions going forward, that's not good unless we do something about it. So that's you, everyone. And it's not easy, unfortunately. I mean, I've worked in development at IBM Hersley for 30 years now, believe it or not. And you know, you look at what some people think about doing, and if you do Google for some of these, you know, getting Java to accept all certs over HTTPS, trust any SSL certificate. Think who would do that in their right mind? But you know, I'm sure some of you are in your own trust manager. However, sometimes, you know, either because you might perhaps a junior programmer and you might not be too au fait, and you think I'm developing this thing in a closed environment, and the API endpoint is validating the SSL trust chain and says it's invalid in your local environment because your local servers are not trusted. Maybe because you've not set them up like that. You think, oh, I'll just type in or insert this trust manager that just trusts all certificates or doesn't perform the validation, and then you go and ship the thing. You know, we've all done something like that, or some of us might have done. The whole world does it. How bad can it be? Well, again, I think you know the answer to that as well. But if you just do a Google search for any of those terms we just mentioned, trust manager, disables, you'll find lots of open source implementations. So, you know, I work in an agile team. Just make sure that when you're doing those PRs that you review them and don't just think, oh, I'm sure it's okay, merge. That sort of thing. We've all done that, I've done that. So, to wrap up, as I mentioned at the beginning, serialization, Java serialization is used widely, from some legacy type application forms to up to the modern day. You can't escape the problem. You just search for in GitHub for implement serializable. You'll get a lot of hits. So, as developers, we need to be responsible, design and code our software securely, and make sure that the bad guys can't exploit any holes that we might have left open. Thank you. I hope I've enlightened you of some of the pros and cons of Java serialization. Any questions? Thank you. Okay. Oh, there's one.
So, what's Oracle's or any Java developers' next biggest idea to fix the problem, or is there such an idea?
Ooh, good question. I'm not aware of one, to be honest, but you know, things move forward, and being aware of the issues. Unfortunately, you make things too simple sometimes. They can get used against you, but they equally make things too complex and we make mistakes. So there's sort of pros and cons of each way. Hi.
Java module API brings strong encapsulation, but on serialization and deserialization side, it doesn't bring any changes, right?
Java modularization.
Module API, yes.
From no, I mean, as I say, it helps you. You can take advantage of certain, you know, limiting. You can reduce your JRE, which can help to a certain extent. But I'm not aware of anything directly that can help you from a specific modularization perspective. Hi.
One more question. We do really use serialization in our production software, and I was very surprised to find out that this automatic generated serialization ID depends on the static methods of the class.
Yes.
We alter the class and some static method and find out that the serialization
Yes,
changed.
that's right.
Why?
Well, because it's been helpful to you. But this is why you need to know what that number means, which is why I explained it. Because generally, if you change the member variables, you're potentially making it non-serializably compatible. But there are ways of doing serializably compatible changes. So if you add members at the end, which you know can have valid defaults of 0, then you know that's a serializable compatible change. And you should therefore specify the serialization version ID as being the same. Don't rely on the generated one.
But I mean, the serialization, the ID is changed even if I add static methods and static fields. They don't participate in serialization at all, but they change the serialization ID. That was our problem.
Ah, okay. Yeah, I'm not sure about that, but I think it's thinking that the class definition is changing, therefore, to be safe, unless you tell me otherwise, I'm going to make it serializably incompatible. So presumably, you have to specify it if you want to be serializably compatible in your use case. Otherwise, it's not going to work. It's going to say, failed serialization. Okay? All right, thank you very much indeed.